Hello students, this video is to review the skill of finding regression equations for given data sets. This is a Common Core Algebra 1 Regent skill that is very important. Let's say the question gives you a data set, either in a table or in a scatter plot, and it asks you to find the equation for a line of best fit. The easiest way to do that, or perhaps the most statistically sound way to do this, is to use your calculator to calculate the regression equation, and then you can use that regression equation to help make predictions. Let's take a look at a few of the types of questions that you might see. In this sample problem, it gives us a table of information from January all the way to December, and it identifies this information as monthly sales and advertising expenditures for all of last year by a digital electronics company. So it looks like monthly sales is one of the variables, and advertising expenditures is the other variable. It asks us to write a regression equation, so while we're annotating, we'll circle that. Write a regression equation describing the relationship between advertising dollars and monthly sales. And it also asks us to round all coefficients to the nearest hundredth. So that gives us a little guidance as to what we're supposed to write. So what we're going to do is take all this information, the advertising dollars, and all this information, the sales, and we're going to put them into our calculator. So I open up my calculator, and I turn it on, and it looks like somebody's been using it before. So you should recall the reset procedure, which is second plus 712. And now that we have a nice clear calculator, we can go into the stat menu. In stat, it gives us a couple of different options, but what I want to do is edit. I want to edit my list of numbers to try to put in the advertising dollars and the sales. So I go to stat edit and I press enter. Now in L1, we usually put the independent variable, the X variable, and that's the first one that's given, advertising dollars. So that information goes in L1. In L2, we're going to put the numbers for sales. Go ahead and do that on your calculator, pause the video, and then unpause it when you're done. Alright, and you can see that I've put all my data into the calculator. I went up to the 12th month, which is December, and I can tell that I've done that because the next line says L2 parentheses 13. This would be the 13th number in the list, and it's obviously blank. The first thing I want to do is just make sure that these data are going to be a linear pattern. It's going to be a linear scatter plot. You don't have to do this every time, but it's a worthwhile endeavor because if it gives you an exponential pattern, for example, you have to use another type of regression. So I'm going to try to look at the graph, but as you know, the graph generally only shows equations. So instead of looking at just this piece, we're going to take a look at this part of the graph, the quadrant 1, and we're going to ask the calculator to show us statistics. The first thing we're going to do is press second and go to y equals where it says stat plot. Now right now all the stat plots, all the statistics are off. I'm going to turn the stat plot on by pressing enter, enter. Now if I go back to my stat plot menu, it says plot 1 is on. Now I'm going to ask the calculator to zoom to the exact stat points. So I'm going to press zoom, and the calculator knows where all the statistics are, so I'll go to where it says zoom stat, which is the 9th one, and press enter. And it looks like from my scatter plot, it looks pretty linear. It looks like it's going from here all the way up to here with a fairly constant slope. There's a couple of scattered points, but that's why it's called a scatter plot. So now that I'm pretty confident that it's going to be a linear line of best fit, I'm going to go back to the stat menu. Remember, we pressed stat edit in order to put in all the information. Now I'm going to go to stat calc. In the calc menu, there's a number of different options. One of our stats helps you find mean, median, mode, that kind of thing. Well, not the mode. The fourth one down here says linreg, which is short for linear regression. So I'm going to press that. And then the calculator asks me, are you sure you want to do that? You say, yes, I'm sure. So the calculator is going to give you a little bit of information. It says y equals ax plus b, which should be familiar to you because this is linear form. This is standard slope-intercept form. Y equals a being the slope, x plus b being the y-intercept. And the a value is going to be 13.899, etc. The b value is going to be 28.645, etc. So we're going to take these and write our equation from them. Alright, it says y equals ax plus b, but you recall that we're supposed to round all the coefficients to the nearest hundredth. So the first coefficient says 13.8996. We're going to round that up to 13.90. So 13.90 is my slope. It's my a value. Then I'm going to put x. The next number is a positive number. It's the b-value is positive, so I'm going to put plus. 28.6457, etc. That turns into 28.65, so 28.65. So I've just showed you how to find the linear regression line, or the line of best fit, for a given set of data. Now I'm going to tell you how to figure out whether it is a strong correlation. It says, do these data suggest a strong correlation? Strong correlation is calculated by something called the correlation coefficient. The calculator's job is to tell us not only the equation for the line of best fit, but it also tells us something called the correlation coefficient, but you have to ask for it. In the calculator, if you press second 0, that brings you to the catalog. We're looking for a selection called Diagnostics On. So we'll scroll down to where it says Diagnostics On. There it is. And when it says Diagnostic On, it says, are you sure? And you say, yes, I want Diagnostics to be turned on. Now I'm going to do the same exact procedure as before. I'm going to calculate the linear regression equation. And as soon as I do that, it's going to give me 2 extra pieces of information. The piece of information we're looking for is R. R is the correlation coefficient. And in this case, the correlation coefficient is 0.890945, etc. This number, if it's very close to 1 or very close to -1, indicates that it is a strong correlation. You should recall that from class. As a quick reminder, refer to this diagram. If the correlation coefficient is -1, it's an extremely straight negative sloped line. As the correlation coefficient gets closer and closer to 0, the data become more spread apart. And then as it gets closer and closer to 1, it becomes a positively sloped scatter plot with the data very close together at r equals 1. So as you can imagine, an R value of 0.89 is very, very close to 1, so it should be a fairly strong correlation. So your answer, your response can be something like this. The R value is 0.891, and that R value indicates a strong linear correlation. So you can see your answer here, and I'll slide the calculator out of the way because it's no longer needed. We're supposed to justify our response, so the correlation coefficient in this case, as I said, 0.891, means it's strong. Go ahead and pause the video if you'd like to copy that down. Otherwise, we'll take a look at the next example. Alright, this next example was actually taken from a Regents exam, so it's a pretty fair estimate of what you're likely to see. It says that Joey watched an online video of a band. He saw it was 843 views, and then he saw it a month later, and it had many more views. As the months went on, it looks like the views also got larger and larger and larger. So it's asking us to write a regression equation that best models these data. We're going to do the same thing that we did before. We're going to try to make a regression equation for this situation, but right now we have a lot of information in the calculator. So let's clear it out. You should recall that the reset procedure is second plus 712, and now all the information is gone. The bad news is we now have to turn diagnostics on again. So let's do that quickly before we do anything else. So we go to the catalog. My shortcut is to press D and go to where it says Diagnostics On. Now the diagnostics should be on. In my Stat Edit menu, I don't have any information, so I'll start putting in the information now. As a brief note, you should notice that for 2 months, Joey forgot to record it, so this piece of information should not be inputted into the table because there's an X value, but there's no Y value to put in there. So let's record the data into our calculator now. Alright, our data are now inputted, so we're ready to take a look at the regression equation. First, let's take a look at the data and see what it looks like. We're going to go back to stat plots, turn the stat plot on, and then we'll go back to zoom and press 9 for zoom stat. It looks like these data are not following a very linear progression. As a matter of fact, this looks like an exponential pattern. So instead of using linear regression, we're going to use exponential regression. So in order to do that, we'll press Stat and go to Calc again. Instead of going to linear regression, because we just said that it doesn't look like a line, it looks like exponential, we're going to scroll down a little bit further to where it says XReg, which stands for exponential regression. When we press Enter, it'll give us some information about the exponential pathway. It says a times b to the x. It gives us the A value, it gives us the B value. And remember that R, which tells us whether or not the correlation, it tells us whether or not the relationship is strong. This R value is 0.99998, really close to 1. So it looks like this regression line is a very, very strong relationship. All right, since that R value, the correlation coefficient, is so high, let's go ahead and use exponential regression as our equation. So the equation should start off with y equals. It says 836.47 is the A value, and we're rounding to the nearest hundredth because that's what it asked us to do before. So 836.47 is the A value. Now the B value is 2.0472, etc. We're going to call that 2.05 because it's asking us again to round to the nearest hundredth. I actually can do this on my computer drawing program. I can put to the x power just like that. So that equation is a exponential regression equation that best models this data. The model is proven to be a very good model because that number is very, very close to 1. All right, at the beginning of the video, I told you that regression equations were sometimes used to make predictions about data. In this case, it's no exception. Letter B, question letter B says, as shown in the table, Joey forgot to record the number of views after the second month. So what we're going to do is use the equation that we just found to estimate the number of full views of the online video that Joey forgot to record. So our X value in this case, the number of months, we're going to use 2. Forgot to record, well, we'll try to determine what that is because that's going to be the Y value. So the correct way to calculate this is to take this regression equation and simply input X equals 2. Pull down our calculator here, and we'll input 836.47, and we're multiplying by 2.05, and that 2.05 is going to be put to the power of not x, but 2, the number of months we're trying to use to predict. The answer is 3,515.265, etc. It's asking to estimate the number of full views, so that's the thing that we're going to annotate here. We're looking to estimate the number of full views that Joey forgot to record. Well, I'm not going to write 3,515.265 views. That wouldn't make much sense. We're asked to estimate the number of full views. So I'm going to round to the nearest whole number. It looks like 3,515 views. And if I wanted to get full credit, I'd write out what I actually did. So it should look like this. And this should get us the full points on the Regents exam because, of course, you know you're supposed to show your work. All right, this was a video on regression equations, which is a Common Core Algebra 1 Regents skill. Good luck studying.